Welcome back to the Deep Dive. Today we are taking a pretty dense stack of documents. We've got the Brothers AI version 7.0, technical clarifications of the older v6.0 context, and a general YouTube overview. And we're going to try and piece them together.
And, what they're describing here isn't just another software update.
No, not at all. They're talking about a blueprint for what they call a total architectural inversion of how we think about our digital lives. Well, it feels like a design for a whole new digital civilization, really.
And one that's custom tailored for maximum user privacy. That's the absolute core of it, the tension we really need to dig into right from the start.
The AI trilemma.
Exactly. The concept designer calls it the AI trilemma. It's this seemingly impossible balancing act between three things you absolutely need. Radical efficiency.
So speed.
Speed, yes. Then verifiable truth. And finally, the really tough one, absolute user privacy. And, historically, AI has always stumbled here.
Because to get that scale and speed, you had to put everything in the cloud.
And in doing so, you sacrifice privacy. It was just the accepted trade-off.
So the Brothers AI solution, which this v7.0 document really solidifies, is to flip that model on its head.
Completely. The core intelligence, the sovereign AI they call BROHOME, is moved entirely local. It lives on a mini PC that you own, physically inside your house.
And that's the foundational contract, isn't it? But I guess the big question is, why is that isolation so philosophically necessary? I mean, why couldn't it just operate as, say, a super secure cloud instance?
Because true sovereignty requires physical control. It just does. If your core intelligence layer, your brain, is local, it fundamentally changes the entire trust model.
How so?
Well, for one, the operating system, BROHOME, operates with basically zero latency. We're talking around 0 milliseconds for any internal thought process or for retrieving your own personal data.
Because it never has to make that round trip to a server farm somewhere.
It never has to wait on the internet. It's right there. So it's not just that it's faster, it completely eliminates the opportunity for a third party to intercept or misuse your thoughts or your history while they're being processed.
Okay, so let's break that down. What is BROHOME actually interacting with on that little mini PC to maintain this perfect isolation?
It really comes down to two dedicated local knowledge systems. First, you have the local 100-gigabyte knowledge base they call books.
Right, the encyclopedia.
Exactly. It's a static, verified encyclopedia that's constantly being updated. This gives BROHOME its immediate factual context for almost anything, so it doesn't need to go out and query Wikipedia or a search engine for basic facts.
So that's the verifiable truth part of the trilemma solved locally.
Precisely. And the second piece, which is just as critical, is the ISU user memory.
And this is where all my personal stuff lives.
All of it. Your history, your preferences, your calendar, everything. But it's stored in a really clever way. It's encrypted, but it's also fragmented and broken down into what are essentially meaningless codes.
So it's not just locked, it's shattered.
That's a great way to put it. And the only thing that knows how to reassemble those fragments into coherent memories for BROHOME to use is the local coherence algorithm, which is unique to your specific mini PC.
So if someone were to physically seize the hardware and crack it open,
they just find digital gibberish, useless fragments.
Okay, so the foundation is set. We've got this perfectly private, sovereign OS in a box. It's defined by total isolation and near-instant local processing. But, and this is the big but, a sovereign AI is pretty useless if it just sits in a vacuum, isn't it?
That's the central tension. It has to interact with the outside world and needs to connect with commerce, emergency services, live data feeds. Everything.
And that's really the critical problem that v7.0 is trying to solve.
That's right. So the core mission of this deep dive today is to unpack exactly how this isolated, super private core intelligence can safely and efficiently interact with what is, by definition, an untrustworthy, noisy external world.
And v7.0 gives us the critical architectural details on that external service layer, which they call the fingers ecosystem, and this really revolutionary visual interface that ties it all together. Vision. Okay, let's unpack that. Let's dive right into the architecture designed to bridge that gap between BROHOME's little isolated box and the entire external world.
And the v7.0 documentation, it actually starts with a really important clarification.
About its external service layer, right, I saw that. In the older concept descriptions, they used the term inverse API to describe how outside services would connect, but now there's a technical correction.
Yes, and that correction is important. The term inverse API was, conceptually very powerful.
Because it got the idea across that you're flipping the model.
Exactly. Instead of the client, BROHOME, going out and querying some big centralized server, the client stays home and the services are just kind of waiting to be called.
But they've refined that.
They have. In the v7.0 docs, they've shifted to the more precise term, responsive fingers or fingers with SDK plugin.
Okay, so why was responsive fingers considered technically more accurate? I mean, what does it emphasize that the old term didn't?
It really focuses on the crucial operational concept, which is a combination of distribution, autonomy, and this idea of decentralized self-assignment.
Okay, that's a mouthful. Let's break that down.
Well, the term API still kind of suggests a structured interface between two systems, often controlled by a single platform, a single company.
Like a gatekeeper.
A gatekeeper, exactly.
Yeah.
The fingers model is all about shattering that centralized control. The service provider, the finger itself, maintains total operational autonomy.
Meaning it decides for itself.
It accepts or rejects a request based entirely on its own internal real-time status. It doesn't need approval or direction from some central dispatch system.
So it removes a middleman. But you're not just talking about removing, say, a payment processor. It's removing the logistical coordinator.
Precisely. If I'm a service provider, I decide if I'm available, not some central platform's algorithm.
And that's the point that, as you said, has some really significant societal implications.
It does. If you can remove that central bottleneck, you can gain massive efficiency, especially in scenarios where every second counts.
The police emergency scenario.
We have to look at that example because it shows this decentralized self-assignment idea in action perfectly.
Okay, walk us through it step by step.
Yep.
What happens when a user has a real emergency and needs police help right now?
Right. So the user, probably through a verbal command to BROHOME, reports an emergency. The system assigns it a level 127, which is maximum urgency.
And BROHOME doesn't dial 911.
No. It doesn't call a central dispatch. Instead, it formats a tiny, ultra-simple signal that just requests level 127 assistance at the user's specific coordinates.
And where does that signal go?
It goes out simultaneously to all registered fingers police within that geographic area. It's filtered and managed by the secure intermediate layer, Port AI, which we'll get to later.
And the response is then governed by the internal state of each individual patrol car's system.
Exactly. So each patrol car is running its own finger SDK. And that SDK is constantly checking the car's current internal state. Let's say patrol car A is in the middle of processing a low priority incident.
Like a traffic stop or something.
Right. Its internal status might be, say, 30 out of 127. It's busy, its resources are being used. So based on its own programmed logic, it automatically chooses not to respond to that level 127 alert. It just ignores it.
But patrol car B is, on a coffee break or just finishing up and is available for deployment.
Its status is 127-127. It's fully available. The finger attached to that car system automatically responds to the query, accepts the service request, and immediately receives the routing and incident details.
So the system instantly assigns the closest, highest priority, and most importantly, available and autonomous resource.
And the innovation there is it's profound. The system completely removes the manual, human-centric police central station bottleneck. It's all gone. It's replaced by this distributed, intelligent, and instantaneous machine response.
And that speed gain. Eliminating the latency of a human answering a call, processing the information, routing it to a dispatcher who then manually assigns it. That could be life or death in a catastrophic scenario.
It moves service coordination from a classic bureaucratic hierarchy to a distributed mesh network. It's just a fundamental change in how you conceptualize service infrastructure.
And that need for different kinds of communication, the instant availability check for an emergency versus a constant stream of news data, that must be why v7.0 details two distinct types of fingers.
That's exactly it. This modularity is key. You have to cover all the different economic and operational needs across a whole ecosystem.
So let's contrast the two, starting with the first one. The broadcasting fingers. What's their operational model?
Broadcasting fingers they're basically designed for continuous high-volume information delivery. You can think of them as data emitters.
So they're always on?
Always on. A 24/7 transmission model. They don't wait for a specific user to ask a question. They are constantly pushing data towards the Brothers AI ecosystem. They're like dedicated fire hoses of information.
So this would be things like major news agencies, you mentioned Tillum from the sources, or meteorological services giving constant weather updates.
Or real-time stock market data flows. That's a perfect example. They're just delivering raw, time-sensitive content streams.
It also mentions large content streams like TikTok or YouTube if they were to integrate.
Yes, exactly. And because they're providing this continuous flow, their economic model is different. It's managed by the system's economic gatekeeper.
Okay, hang on. We need to pause here because this keeps coming up. The economic system, BROHOME, we need to clarify its role right now. Is it just a passive payment processor like a PayPal, or does it have a deeper, more regulatory role in this?
That's a crucial clarification, and we need to make it right here. BROHOME, the Brothers AI commercial entity, is much, much more than a payment app. It functions as the economic gatekeeper and the identity validator for the entire network.
So you can't play in the sandbox without their permission?
You can't. Every single finger, whether it's broadcasting or responsive, must be registered and validated by BROHOME to operate.
And what does that provide?
It provides a baseline level of identity verification and, critically, accountability. So for these broadcasting fingers, BROHOME is what tracks the volume of data they transmit. And the payment model is usually a monthly subscription or some kind of volume-based fee.
And technically, the provider just maintains their own servers and points that data stream at the system's secure perimeter.
That's the flow.
Perfect.
Yeah.
So BROHOME validates who you are and manages the money. Now, let's compare that continuous push model to the second, more interactive type, the responsive fingers.
Responsive fingers are let's call them the active utility-based participants. They're completely dormant until an active query comes in from BROHOME.
They only speak when spoken to.
They respond only when interrogated. And as we saw with the police car scenario, they have that crucial self-evaluation capacity. They have the built-in logic and autonomy to decide if they are capable, available, and willing to fulfill the request at that exact moment.
And the examples here are services that need that availability check.
Yeah.
Emergency services, taxi systems, maybe professional consultations with lawyers or doctors.
And critically for the marketplace, accessing real-time stock and inventory data from local stores.
And their economic model is completely different. It's not about volume.
No, it's tied directly to action. It's based on microtransactions, payment per individual query.
So if I, as a user, ask the system a question,
Like, is the lawyer available for a call, or do you have coconut oil in stock?
and the responsive finger provides that verifiable answer or completes the reservation.
That finger collects credits, micropayments for the specific service it just rendered.
And that dependency on query payments and their autonomous nature leads us straight to the technical implementation, the SDK plugin. This seems like the absolute key to getting mass adoption without forcing the entire world to switch operating systems.
Oh, absolutely. The source material really highlights this as a major selling point. Responsive fingers are designed to use a very thin SDK plugin that gets installed into the provider's existing systems.
So think about a local grocery store.
Right. They don't have to throw out their entire inventory management software that they've been using for 10 years. They just install this SDK.
So the SDK is basically a universal adapter or translator.
That's a perfect way to describe it. It has a listener component that's just waiting for a query from BROHOME, an internal state reader that knows how to access the store's current POS or inventory database, and an automatic responder that decides whether to accept the reservation and payment.
It just dramatically lowers the barrier to entry.
Immensely. Organizations get to keep their legacy infrastructure, their existing POS, their scheduling software, their operational systems. They install this little SDK, and suddenly they're completely compatible with this hyper-efficient, query-driven Brother AI ecosystem.
All while keeping their complete business autonomy over their own pricing and availability.
It's integration through minimal intrusion.
Okay, so we've established this secure, decentralized, incredibly responsive architecture that's powered by these fingers. Now, how does an average person, me, interact with this massive, real-time, global service network?
That's where vision comes in, and it's described as nothing less than the evolution of the traditional browser, but built for the Brothers OS.
It's the front end.
It is the ultimate front end for this entire Fingers network. It's designed as a unified 3D and 2D interface that merges geolocation, commerce, and content streams into one continuous, fluid experience. It lets you see the entire ecosystem operating around you.
The documentation breaks vision down into 3 distinct modes. And mode 1 is, it's the most familiar one. It's designed for comfort, right? The applications portal.
This is your on-ramp. It's the traditional content launcher. It gives you direct access to conventional non-finger-based apps like YouTube, Netflix, maybe a legacy web browser instance for websites that haven't integrated.
It's the digital comfort zone.
Exactly. It's a necessary and familiar starting point before you ask users to dive into the radical new structure of the rest of the ecosystem.
Okay, but mode 2, this is where things get really interesting. This is the radical innovation, the promised fusion of utility and social interaction.
Right.
We're talking about geolocation, but presented not as a flat map like Google Maps, but as a horizontal feed using 3D miniatures of all the nearby fingers.
This feature, it weaponizes proximity. It makes geographical exploration intentional and, frankly, fun.
So instead of just endlessly scrolling some abstract algorithmic feed, you're presented with a real-time geolocated feed of the physical reality that is literally all around you. And crucially, you, the user, can adjust the radius of this feed, 500 meters, 3 kilometers, the whole city, or even the whole world, and you see a unique, visually distinct 3D miniature representing every registered finger.
And that's not just businesses.
No, it's every finger. A small business, a high-level service like a hospital, or even another user who has opted into public visibility.
So if I'm walking through my neighborhood and I activate Vision, I'm literally seeing a carousel of these little digital representations of the actual coffee shop on the corner, the pharmacy, the local mechanic, and the available taxi fingers that are driving around nearby.
Yes. And under each one of those miniatures is the element that really defines its hybrid nature, Vision Digo Key.
Which translates to vision, I say that.
Right, and this is the fusion feature. It's blending the raw utility of a Google Maps or a Yelp with the instant communication of something like X, formerly Twitter. It's the daily status update, but it's tied irrevocably to a physical location. This sounds like a really crucial mechanism for real-world engagement. Give us some specific examples of what kind of content gets published under Vision Digo Q.
Well, for businesses, it's all about urgency and specificity. So a restaurant might publish, "Today, special ham offer HTSWSL.
HTSWSL.
Has determine our stock while supplies last." It's a message with an inherent built-in expiration date and verifiable physical availability. It's not a coupon for next week, it's an offer for right now.
And what about for users?
Users, on the other hand, might share a quick recommendation, great service at this lawyer finger today, or just a status update that's tied to their current location.
The strategic difference here, and the documentation really hammers this point, is that this content is tied to a real physical location and a registered accountable finger.
Yes. It's not abstract content. It's not an algorithmically generated infinite chronological feed that's designed to maximize your engagement metrics. It is intentional geographical exploration.
That feels like the philosophical break from current social media.
It is. This system is designed to generate engagement and, actual pedestrian traffic without relying on invasive ads, endless scrolling, or push notifications that plague us now. Businesses benefit enormously because they can use these urgent, limited messages, that HTSWSL model, to drive immediate in-person discovery and impulse buys.
They aren't trying to sell you something a week from now.
They want you to walk in the door right now.
So when I, as a user, select one of those 3D miniatures on the carousel, what are my core interaction points? What can I do?
The miniature expands. If it's a shop, you immediately see its real-time inventory and pricing, which we'll get to next. If it's a person or another user, you might be able to initiate a video call.
And it mentions a live stream indicator.
Right. If that finger is broadcasting an event from their location, maybe a band playing at a bar, a red indicator flashes on their miniature, you can tune into a live stream directly from there.
And because accountability is so central, you can also see their history.
Absolutely. You see the full history of all their Vision Digo Q messages. This provides a public, auditable track record of their current offers and, just as importantly, their past conduct.
Okay, so Mode 3 takes that geographical, real-time context from the carousel and transforms it into the core commercial engine. This is the local marketplace, a system built entirely for buy and pickup.
And it's a hyper-local challenge to the global logistics model of traditional e-commerce, like Amazon.
The functionality here seems to be defined by precision and speed.
It is. The user searches for a specific product, and Vision instantly queries the entire local network of responsive fingers. The display immediately maps out the businesses within your adjustable radius that have that exact product in available stock right now.
Not ships in 24 hours, but on the shelf 200 meters away.
Exactly. You get an instantaneous price comparison, the ability to reserve that physical item, make an advance payment using your query credits, and then you just walk down the street and pick it up.
This solves a massive friction point that we all experience daily. Driving to 3 different stores only to find they're all out of stock, or waiting 3 days for shipping for something you need tonight.
Let's walk through the coconut oil case. The source material uses this as a really clear example to illustrate the practical flow.
Okay, let's do it.
All right, so imagine a user is walking home and they suddenly realize they need a specific brand of coconut oil. They activate the conversational interface. BROHOME, open Vision, and search for coconut oil near me.
And because Vision can operate invisibly in the back end, BROHOME can just process this request without the user needing to open a single app or website.
Right. So internally, Vision executes a massive parallel query to the responsive fingers of all the registered businesses in the area, grocery stores, health shops, pharmacies, you name it.
And the responses come back instantly.
Instantly. So BROHOME might verbally relay back to the user. 2 businesses have stock. Perfumeria Hulabian is 200 meters away, priced at 15 credits. And Carrefour Express is 450 meters away, priced at 14.5 credits.
And the transparency continues because BROHOME also mentions ads levels.
It does. It might add, Hulabian is N1 featured, Carrefour is N1, and N2 featured. This tells the user that those businesses are paying to be highlighted on the geolocated feed. You always know when you're seeing an ad.
So the user chooses the closer, slightly more expensive option, maybe because they're in a hurry, and says, guide me to Perfumeria Hulabian, reserve and pay just in case.
And the technical process behind that is instant. BROHOME deducts the 15 credits from the user's account, that payment is recorded, and the reservation notification is sent instantly to the Perfumeria Hulabian's responsive finger SDK.
Which then updates their internal stock immediately. 1 coconut oil is now reserved.
Correct. And GPS navigation is activated for the user on their device.
So what happens when the user arrives and actually picks up the product?
The business confirms the pickup. They might have a simple terminal or a POS integration that communicates with their finger SDK. They just tap confirm.
And that triggers the final step in the system.
Right. BROHOME holds that payment in escrow for a short claim window, usually 24 hours, to allow for any returns or disputes. Once that window closes without any issues, the credits are transferred directly to the business's BROHOME account.
This whole process, it highlights several major competitive advantages. First, that conversational interface completely eliminates app navigation.
Second, the low technological barrier. Small businesses only need a simple inventory panel that the finger SDK can read. That makes it incredibly accessible.
And crucially, it gets rid of the need for product photos and endless optimized product descriptions.
The transaction is based on verifiable text format, stock availability, location, and price. All of it is integrated seamlessly via that query credit system. It's an incredibly lean, efficient, and hyper-local commercial engine.
But let's introduce a challenge here, something that critics might bring up. If the payment is instant, but the business only gets the money after pickup and after that claim window closes, what stops the business from gaming the system?
How so?
Well, say a high-demand item is reserved. The business knows the user is already on their way. What's to stop them from canceling the order, selling it to someone in the store for cash, and just claiming it was a system error?
Okay. That's where the transparency and accountability enforced by BROHOME and the audit systems come in.
The oversight layers.
Yes. Every single transaction is a traceable event tied to that finger's unique identity. So if Perfumeria Hulabian frequently reserves items, takes the payment, and then cancels when the user arrives, Art or AI, which audits the quality of the data flow, as we'll discuss later, flags that anomaly immediately.
So repeated bad behavior has consequences.
It absolutely does. Repeated service failures or cancellations will negatively affect the finger's reputation score within the ecosystem. This could lead to warnings, fees, or eventually BROHOME could just revoke their registration entirely. The economic gatekeeper enforces quality control through a verifiable transaction history.
We touched on this briefly. The fact that vision doesn't always have to be a visual component, even though it's the main interface. It can operate in what they call invisible mode or back-end mode.
Yeah.
Why is that so critical for the overall utility of Brothers OS?
Because BROHOME is designed to be a true companion OS, not just an app launcher you stare at. If you're outside walking the dog, or you're just talking to your smart TV that's currently turned off, the system has to maintain its full functionality.
So vision is always running in the background.
It's always running internally on the Brothers OS, constantly updating the local maps, the directories, and the proximity data that it stores in the Port AI cache.
So if I ask BROHOME, where's the nearest place that sells organic dog treats? and my phone screen is off.
BROHOME just queries Vision internally. Vision performs the geolocation and the finger search. It receives the real-time stock data from the local pet stores, and then BROHOME takes that data and simply responds verbally to you.
So it might say,
Perfumerie Huilebien has 3 bags left, 500 meters ahead on your left. The system provides the full functional utility, including complex location and inventory data, without ever requiring a visual output. It maintains that conversational flow and the hands-free nature of the interaction.
it's the difference between needing Google Maps to show you the entire visual map versus just relying on the voice navigation that simply tells you turn right in 50 meters.
Exactly. The underlying complex system is still running at full power, but the output is tailored for your current context.
Okay, we now arrive at what is probably the most complex, but also arguably the most essential part of this entire v7.0 clarification. The security architecture.
This is the bedrock.
We have BROHOME, perfectly isolated and private, but now it needs to interact with millions of external, untrustworthy fingers. How on earth do you maintain that promise of total privacy and isolation while accessing data from a potentially compromised external world?
The answer is the glass box.
The glass box.
This architecture is, I would say, the single most important philosophical achievement of the entire system. And the fundamental concept is that BROHOME operates inside a hermetic, bulletproof glass box. This is the deep analogy you have to hold in your mind.
So BROHOME can see the outside world through the glass.
And it can send out signals by, tapping on the glass. But, and this is the non-negotiable part, there is never a direct bidirectional data connection that could compromise the local OS. It only reads information passively.
I'm thinking of a bank teller analogy. BROHOME is the teller, safe inside the vault. The external world, the fingers, they're the customers.
Yeah.
They can only communicate through a protected intermediate mechanism.
That's a perfect analogy. And that protection is layered. We absolutely have to break down these 4 security layers, starting with the safest zone, layer 1. Okay, so layer 1, BROHOME, maximum trust zone. This is the core OS, the sovereign intelligence. It's defined by its complete isolation and its speed, that near 0 millisecond latency.
And it's the only entity in the whole ecosystem that operates using its own local trusted code.
That's right. Its data access is restricted entirely to local secure sources, its own ISU user memory, the book's knowledge base, and this thing called the fingers window, which is always strictly read-only.
And its communication mechanism. It's deliberately crippled for security, isn't it?
Yeah.
It can't just send out a complex request that could carry some kind of viral payload.
Correct. BROHOME can only send out these ultra-simple restricted requests, we're calling them signals, to the next layer, port AI. The requests have to be basic, verifiable phrases like temperature in Madrid or available taxi coordinates.
So there's a hard logical separation.
It's an absolute wall that prevents BROHOME from formatting or injecting any complex external-facing code. The communication is absolutely unidirectional. BROHOME asks and port AI processes. It can never passively accept incoming raw data.
And that inherent simplicity protects it from complex remote code execution attempts.
Yeah.
Which brings us to layer 2, port AI, the intelligent firewall. This layer seems to shoulder the greatest security burden of all.
It really does. Yeah. Port AI is the single point of contact between the secure local core and the untrustworthy external world. It receives those simple signals from BROHOME, it translates them into the necessary protocol to query the external fingers, and it coordinates with Vision to gather the required data.
But its most critical function is on the return trip.
Oh, by far. It's the border patrol agent, and it performs a deep inspection on every single piece of data that tries to cross the perimeter.
It's not just checking passports.
No. Port AI validates and sanitizes all responses. It's designed to detect suspicious content. It filters out all executable code, even seemingly harmless scripts that might be hidden inside data packets, and it converts the raw external responses into secure, static data formats.
Like plain text.
Plain text, safely rendered images, or validated map coordinates. So if an external finger is compromised and tries to send a 0-day exploit hidden inside an inventory update, Port AI is designed to recognize and neutralize that payload before it gets anywhere near the secure environment.
And once it has scrubbed all that data clean, where does it put it?
It publishes the secure result to the fingers window. It is literally, to use the analogy, sticking the clean, static result onto the outside of the glass box for BROHOME to read.
And what about the cache?
Right. A critical component of Port AI is its cache. It stores pre-validated local data, things that don't change often, like stable maps, finger registration directories, metadata, which allows it to answer many local queries without ever having to expose itself to the internet at all.
Which then brings us to layer 3, fingers window, the quarantine zone. So this is the bulletproof glass itself, plus the internal notice board where Port AI posts things.
This is the read-only sandbox. Data arrives here only after it has passed the rigorous filtration of Port AI. It is strictly a data zone where information is published.
And the core security guarantee here is absolute.
No code execution is possible, ever. BROHOME and you, the user, passively read static data from this zone. The analogy holds up perfectly. The bank teller, BROHOME, can read the newspaper, the data that's taped to the glass, but that newspaper is inert. It cannot physically interact with the ink or the paper, and it certainly can't execute a malicious script hidden inside the classifieds.
So this is where the continuous streams from the broadcasting fingers are displayed, and where the data from responsive fingers, like the real-time inventory, is temporarily posted. And all of it is secure, static data.
And finally, that leaves us with layer 4, fingers. The external world untrustworthy. This is the Wild West.
External services potentially compromised running on external infrastructure.
And the ironclad rule enforced by Port AI is you never speak directly to BROHOME. All communication has to pass through the purification process of Port AI, which maintains that conceptual air gap.
Okay, let's review that complete security so one more time just to tie it all together and see how that isolation is maintained.
Let's do it.
The user asks BROHOME a question. BROHOME sends a simple signal. Port AI leaves the secure zone, it goes out to the untrustworthy fingers, fetches the data, sanitizes it completely, removing all potential threats, and then it publishes that clean, static result to the fingers window.
And BROHOME, operating safely inside its glass box, passively reads that secure result from the fingers window and then generates its conversational response back to the user.
So the key takeaways for you, the listener, are that the no bidirectional connection guarantee is absolute.
And Port AI functions not just as a firewall, but as a dynamic content transformer. And that conceptual air gap, that logical separation between the trusted and untrusted environments, is maintained at all times.
But this places an enormous functional and, frankly, ethical burden on Port AI. I mean, the system has to be perfect because it's the sole gateway. So what's to stop Port AI itself from becoming compromised or from just letting malicious data slip through?
That's a fantastic question, and that's why the architecture includes independent surveillance layers. It can't rely on self-monitoring alone.
So who watches the watcher?
The first layer is Arbiter AI. Arbiter's only job is to examine the data flow after Port AI has already processed it. It audits the quality of the responses from fingers, and it detects anomalies in their behavior.
So if a finger starts sending back corrupted or inconsistent data,
Arbiter flags it. And if Port AI somehow fails to neutralize a malicious packet, Arbiter analyzes that failure in order to update Port AI's scrubbing algorithms for the future.
And then for the deeper ethical and behavioral oversight, we have the three sisters.
The three sisters represent a completely separate surveillance layer. They're designed to monitor general system behavior, not just technical anomalies, but ethical consistency.
So they're looking for fairness, bias, manipulation.
Exactly. For instance, if the fingers ecosystem seems to be systematically excluding certain service providers or favoring one political viewpoint in its search results, the three sisters are programmed to monitor and report those inconsistencies by voting on ethical breaches.
They're providing a vital check on the overall fraternal and ethical environment that the ecosystem promises to maintain.
They're the conscience of the machine.
We've now thoroughly established the security structure, but this entire system is completely dependent on the flow of commerce and information. So how does the economic engine, BROHOME, actually integrate into this isolated, secure architecture? And what advanced applications does v7.0 enable by leveraging this unique structure?
Well, as we touched upon earlier, BROHOME is deeply, deeply integrated into the operational flow. It acts as the necessary regulatory structure that makes the whole fingers system trustworthy in the first place.
It's the economic gatekeeper.
The gatekeeper that links a real physical identity to a digital service capability.
Let's go back to that mandatory registration requirement again. Why is it so non-negotiable that every single finger has to be registered with BROHOME to even operate?
Accountability. It's that simple. BROHOME validates the real-world identity and, where necessary, the credentials of the service provider.
So a Dr. Finger would need to have their medical license verified.
For example, yes. And without that BROHOME registration, The finger cannot communicate with port AI or transmit any data to the finger's window. This effectively blocks untrusted or anonymous actors from participating in the regulated economy and from getting access to that hyper-efficient query system.
So if a police finger fails, you know exactly which validated entity is liable.
Exactly. And that registration, in turn, defines the monetization types that finance the entire system, as V7.0 clarifies.
So we have the two main economic flows, and they're derived directly from the two finger types.
Right. You've got subscriptions for the broadcasting fingers, which is based on their constant data flow, and you have query micropayments for the responsive fingers. Every individual service rendered or question answered incurs a tiny fee.
And this model ensures that value creation is directly compensated in real time.
It does. And then there's the transparent advertising model, the mentions ads, which is explicitly tied to that vision interface.
And this is how the system handles visibility without falling into the trap of invasive ad tech.
Exactly. When Vision displays that geolocated feed, the 3D miniatures, businesses can pay BROHOME a fee to have their miniature highlighted or featured more prominently.
And this fee is categorized into levels.
N1 for basic highlighting, and N2 for premium placement or maybe some additional features. But this system ensures that all commercial visibility is tracked, paid for, and crucially, transparently displayed to the user.
Remember BROHOME telling us about the N1 and N2 levels in the coconut oil example?
The user always knows when they are looking at a paid placement.
And that transparency is so critical because it fights against that passive manipulation we see on other platforms where algorithms just subtly favor paying entities without telling you. Here, the commercial bias is explicit and verifiable.
It creates a complete audit trail for all advertising, tied directly to the finger's identity and its real-world service delivery.
One of the most forward-looking use cases that's detailed in V7.0 is how the system leverages its architecture, specifically that combination of local sensors and economic incentives to facilitate citizen crowdsourcing.
Right, primarily for high-integrity, hyperlocal data like traffic and environmental conditions.
And this moves beyond just simple reporting.
It uses that economic incentive system to generate highly reliable hyperlocal feeds by merging verifiable official data with a massive influx of real-time user-generated data. The goal is to get a consensus-validated view of reality that's constantly being refreshed.
So the mechanics. It starts with volunteer users installing simple sensors, thermal, traffic counters, air quality monitors, on their mini PCs or other associated local devices.
And that raw data is captured locally by BROHOME AI, that's the machine intelligence layer, and then it's transmitted securely into the system's collaborative memory layer, which is called ISU Air AI.
And crucially, the source material notes that this crowdsourced data has a built-in limited lifespan of only 24 hours.
Which is key. This guarantees that the crowdsourced information is timely and transient. It prevents this collective permanent storage of location data that would violate the core privacy principles of the system.
But the genius part seems to be the hybrid validation. How does this system make sure that a volunteer sensor isn't just submitting junk data, either by accident or maliciously?
The aggregated crowdsourced data is validated by consensus. So, for example, the system will check if, say, 8 out of 10 nearby sensors are all matching a specific high traffic pattern. If they align, that crowdsourced data point is deemed reliable.
And it's not just consensus.
No. That internal consensus is then compared against official data, which is sourced from established broadcasting fingers, like the Municipal Traffic Authority. The combination of massive real-time consensus plus official verification is what ensures the data integrity.
Yeah, the economic loop is what makes this whole thing sustainable.
Exactly. Users who provide that validated, reliable sensor data receive microquery payments for their contribution, and it's all managed automatically by BROHOME.
So it transforms data contribution from simple altruism into a reliable, economically reinforced source of integrity.
And that powers applications like real-time traffic jam information or street-level parking availability. It establishes a marketplace for data integrity, and it's paid for by the utility fingers that consume that data.
The V7.0 documentation also reinforces the phased approach to implementation. They're prioritizing security and local function over just a massive external deployment.
Oh, the roadmap is a philosophical statement in itself. Phase 1 focuses exclusively on the core local system, BROHOME, books, ISU. That's it.
Then Phase 2 introduces the secure connection.
Port AI and the glass box architecture. And it's only once that secure foundation is proven to be solid that basic vision appears in phase 3. The marketplace transactions don't even arrive until much later in phase 5.
And the complete ecosystem is phase 6.
Security and isolation come first, always.
Finally, the documentation leaves us with a series of crucial and frankly very challenging open questions. Technical, legal, and commercial questions that the concept acknowledges have to be solved before any kind of deployment. These are the real-world friction points.
And on the technical side, the question of scalability is paramount. I mean, how does Vision reliably handle millions of simultaneous fingers, all generating constant updates and status changes while still maintaining that near instantaneous response time?
That's a huge challenge.
And furthermore, the system has to clearly define the malicious data algorithms that Port AI uses. What specific methods does it use to detect novel, zero-day exploits or data that's cloaked as benign text?
And then legally and regulatorily, the challenge of a global deployment is just. It's incredibly complex. The authors explicitly ask about GDPR compliance in different regions, especially given the fragmentation and localization of personal data.
And maybe the most complex liability issue of all, if a responsive finger fails to deliver a critical service, say a certified doctor finger gives bad advice, or a police finger fails to respond because of an SDK error, what is the legal liability chain?
Who's at fault?
Does the liability fall on the finger provider, the doctor, or the police department? Or does the architectural intermediary, Port AI or BROHOME, carry any responsibility for validating the quality of the service flow? These are massive questions around technological trust.
And commercially, they have to address the financial regulation for the query credit system, which is acting as an internal currency and micropayment processor. And then just the adoption model. How do you incentivize large, often change-resistant public institutions like a national fire department to integrate a third-party SDK into their highly specialized legacy systems? #outro. This deep dive into Brothers AI v7.0 really reveals a highly structured, philosophically driven design. And it's one that aims not just to incrementally improve AI, but to fundamentally reverse the security and privacy flaws that are inherent in all of our current centralized architectures.
We've focused on 3 critical v7.0 takeaways today. First, the refined finger system provides true, verifiable autonomy for service providers, letting them self-assign based on their own internal state, which eliminates those logistical bottlenecks.
Second, Vision is the disruptive innovation here. It's the killer app. It fuses commerce and social interaction based entirely on immediate, real-time geolocation and verifiable inventory, and in doing so, it moves our digital interactions back into the physical world.
And third, and most importantly, the glass box architecture is the system's core promise. It's how it ensures maximum user privacy through BROHOME's total isolation. And it accomplishes this by safely navigating the untrustworthy external world using that intermediate Port AI and the read-only fingers window. It's just an unwavering commitment to architectural integrity.
And this focus on fundamental design integrity, it brings us right back to the author's stated purpose behind releasing all of this comprehensive documentation. They say, I am not looking to launch a startup tomorrow. I am looking to start a conversation today. I want big tech companies to look at the chassis and ask themselves, why don't we build privacy like this?
And that leads us to our final provocative thought for you to ponder. The efficiency and the reliability of this entire ecosystem are inherently linked to the economic structures of BROHOME. The system mandates transparency and accountability, and it tracks every transaction via query credits. It even rewards citizen-censored data providers financially.
So if the goal is a hyper-efficient, technologically accessible marketplace where every social and informational contribution is tracked and monetized via microtransactions.
Does this reliance on economic incentive inherently commodify all interaction? Does it potentially leave no viable, high-quality space within the ecosystem for purely voluntary, unmanaged, or non-monetized civic interaction? Does the pursuit of absolute efficiency force the monetization of all human behavior? Something for you to mull over.
Thank you for joining us for this extensive deep dive into the Brothers AI collaborative ecosystem. We'll see you next time.